Okay. Hi guys, thanks for staying late, and let's go with the talk. Kubernetes operators: when, why, how. So all opinions are my own. In case you don't know, Kubernetes is also called K8S, just because there are 8 letters between K and S, and that's how they did. So I promised myself that the attendees will learn at least one thing. So if you don't know, I already checked that at the moment. Before we deep dive into Kubernetes operators, we need to understand Kubernetes a little bit better. And the best option to understand it a little bit better is to try to write our own container organization system. So let's try to do that. How current Java developers start to write their applications? We start writing REST API. So here it is. We start write API. What our REST API will do? Our REST API will accept any resource. What will be the resource? The resource can be some kind of the workload. You want to run your application. The resource can be some kind of the config map, like the secrets or the persistent volume definition, etc., etc. So let it be an API that will accept any kind of resource that you want to create. So we got that resource. What we need to do, we need to save it somewhere. So we'll need a database, and etcd is a database that will save into our data that will accept from the user. Then, okay, so we got resource, we save it, and we got a couple of machines where we want to run our applications, but we don't know yet where we want to run it. So we need to write a simple algorithm that will check, oh, you got that much of the memory, you get that much of CPU, and I want to pick that machine for that kind of the workload. So we need some kind of as a scheduler, simple algorithm, okay? So there is a scheduler, but something happened with our application. There are rollouts, we change versions. Sometimes applications got destroyed or got out of memory, etc., etc., etc. We want to control our applications. For that, we'll need to write another application, and this is the controller manager. In case we want to connect our Kubernetes into the cloud, we will also write cloud controller manager that will connect and see how many nodes we have and give us access to some, I don't know, some resources from the cloud, etc., etc. So we covered control plane. We already wrote that. But there is one more thing. We need to run it on the nodes. So if we have like the virtual machine or the node, we will need to have some kind of the application that will reach out to our API, and API will reach out to database and see what should I do on the node called node1. And there will be the response, oh, yeah, you should run these 4 applications. And the kubelet will just do Docker run or whatever. Yep. So that will be the kubelet. But our application needs to connect between. There will be application on node 1, node 2, and they need to connect one to each other. So to achieve that, we need to create some kind of the proxy that will give us this networking within the Kubernetes. So we've wrote a Kubernetes. Let's call it Kubernetes 101. We already did that. Let's move on. Kubernetes uses something what's called declarative approach, and this is a little bit different than imperative approach. Let me give you an example. If my wife will tell me, like, Daniel, go and buy 6x, I will go to the shop, buy 6x, and put this 6x to the fridge. How many eggs do I have? I don't know, because I didn't check how many eggs I already had in that fridge. But my wife can do it like in the smart way. She will put a sticky note on the fridge and wrote on that sticky note, Daniel, I want you to keep 6 eggs in the fridge at any time. So I will need to go every 5 minutes or every hour, check how many eggs are there in the fridge, and in case there will be 4 eggs, I will go to local farmer and buy 2 eggs and put them in the fridge. And that's how Kubernetes operates. That's the declarative approach. It's a little bit different than, for example, Ansible, because if you run playbook Ansible, and if someone, nasty developer, will go to some kind of the virtual machine and do some nasty stuff there manually, the Argo CD will do not know about that. So we need, and with Kubernetes, there's a whole different story. We just defining the ideal world. That's how my cluster should look like. Please. Pretty, please. And that's how Kubernetes works. So if you apply that, you'll see something like that. You know why? You will see something like that just because controller manager will add some kind of the additional details like IPs, quality of services, and other stuff, let's say, and also some kind of the statuses. if you look at the Kubernetes YAML file, you will see that there are always, almost always, there's small asterisks on that, there are always these 5 fields. Why always? Because the config maps are a little bit different. There is data instead of spec. But let's keep to that one. We want to keep things simple. You got these 5 fields. These 2 fields will define you what resource you want to create, update, delete. So, for example, a pod with that kind of the group. API version will give you some kind of the namespace and the group, and the kind is like the name of your class. So package and name, you can think about it in that way. There is the metadata. Metadata are defining resource metadata, like name, labels, annotations, that kind of the stuff. There is spec. Spec is your input. This is a specification of that kind of resource. Imagine you are creating your own Kubernetes. So you have REST API that have single endpoint, you can apply any resource, and then magic will happen with validation, etc., wherever you apply there. So we need to you need to create some kind of the schema. So the specification will be validated against some kind of the schema. We will come to that later. And there is status. Think about the status in Kubernetes like an output from Kubernetes. This is, oh, I did that. From the control manager, you will see, oh, I did that, and here's the status. Here's my output for you, dear developer, that that's happened or this doesn't happen. Okay, so after settling the ground, we will need to answer a couple more questions before we dive into the source code. What is a Kubernetes operator? What is actually? Anyone knows? Or think that knows? Okay, so there will be this one thing right now. So you can read that. Kubernetes native could be any object, resource, custom resource, application, middleware, workload, image, tool, interface, etc., which is designed to run on Kubernetes platform. That's the first important fact. And it runs with its own shared YAML file. This is the simplest definition. So if you are creating application using deployment in Kubernetes, you didn't create the native Kubernetes application. It's not Kubernetes native. To deploy Kubernetes native, you will need to create your own YAML file, like this Grafana file. This is the native Grafana, for example. And there are a lot of native things for Kubernetes, native resources. You can applying API resources, you will see a lot of them. You will see the groups, the names, the short names. The short names, this is because this is something that you can use deploy instead of deployments, or use ing instead of ingress, or instead of persistent volume claim, you can use PVC. So that's just because you created a shortcut there. And we are come to the custom resource definition. So Kubernetes believes in a way like it's called eating your own dog food. So you will use stuff that you already wrote. So we wrote possibility to create some kind of the resources. And to create more resources, we use additional resource to create resource. We'll come to that in a second. So what you can do is to create custom resource definition. And after that, Kubernetes will know what this custom resource definition is. And you just created your own Kubernetes thing, like this thing that you can apply on Kubernetes API. For example, imagine that I wrote like the currency rate. And I will have specification from this currency to this currency from this date. And I want to see exchange rate for this currency rate. Yeah, that's the simplest thing that I can imagine. And after applying, I would like to see something like that. So there will be status somewhere here, and I will to see the rate from this particular day from these 2 things. And also, if I will get kubectl get currency rate, I should see it like in the console with all the fields, all the print tables, that kind of the stuff. How to create such thing? Let's go step by step and create it manually. We will generate that later, but let's start with manual approach. So to create that manually, you will need to create custom resource definition, and this is also a resource that you just apply on Kubernetes. And there are 3 important parts. First, you need to name your resource. So there will be name, there will be group, there will be like the plural name. That's why you can use deployments, and that's why you can use deployment, and that's why you can use deploy or any other field. So it's everything defined here. This one, you use plural name, that's pretty important, and then the group name, and that's pretty important. The validation will not accept anything else. That's the standard now. So that's the first thing. And there are two types of scopes. You know, in Kubernetes, you can have things that are namespace or unnamespace. Namespace are things that you apply on the particular namespace, like they are connected to the namespace. And unnamespace, like the cluster-wide, airbag, etc., or persistent volume. Persistent volume is not connected to any namespace, but persistent volume claim is. Okay. The second part that's pretty important is that we will define versions. There will be version name like V1, V1 Alpha 1, V1 Beta 1. That's pretty important. And there will be these additional values like served, storage. That's a little bit advanced start for the time being. Like the served and storage is what will you store in etcd and what Kubernetes will serve using your controller manager, which will come to that later. But mostly, in 99% of the cases, only two values are true and for the same version. Like, probably you don't want to go other way. And there can be some kind of the sub-resources that you are creating for this resource, etc., etc. And then we need to define some kind of the validation schema. So there will be spec and there will be status. Remember that from a second ago? So the specification, that's the specification. There are a lot of options for validation, like regex, numbers, strings, etc., etc. And there is the status. This is your output. For example, you want to have the state and you want to use that kind of the enum, so they will be validated and these will be the values that you can use and not other values. So we can apply that, kubectl apply that, and after that you will be able to create currency rate. But nothing will happen because we didn't write the code that will use this currency rate and give us as the status. And writing this source code is called creating an operator. And this is the talk after like the 15 minutes of the introduction. So we created custom resource definition. We, as a user, can modify this custom resource definition, apply, create, delete, update. And there is the operator. Operator is an application that has very, very defined standard that watch the changes on the custom resource definition. So you're connecting to stream of events from the Kubernetes that will inform you that something changed within the custom resource definition that you ask for. For example, I'm asking, oh, I'm an operator, and I want to see all events from currency rate, because I will be operate on currency rate. And after that, you will start receiving change events. You can do whatever you want with that, and then using the same API, you can adjust state of your application, like changing status or even changing specification. But beware, if you change specification, then again you will receive events. So it's pretty easy to come into the endless loop. There are three pillars for Kubernetes operator. The first one is build, test, iterate. It's called SDK. The second one is how to install, manage, update operators. It's called OEM. And there is the Operator Hub IO page, where you can publish and share your own operators. There are plenty of operators. You can go through them, see some kind of, maybe get an inspiration how to proceed. But the more important thing that more important question that we need to answer is when to use operators. Always, never, sometimes, barely. So there are some popular use cases like infrastructure automation. Imagine that you are working in DevOps team and you want to create a lot of Postgres databases for your team and generate passwords for the user, etc., etc. So maybe instead of creating that manually or wherever, you can create your own Postgres. And there is a Postgres operator, obviously. Maybe you can create a little Postgres and it will generate everything for you. Maybe your application is very complex, a lot of deployments, network policies, databases, persistent volume claims, etc., etc. Maybe that's the case. Maybe backup restore, like for the Postgres, is very good operator to do backups and send them out to S3 or any kind of the bucket or FTP server, etc. Maybe you want to connect to external services because Kubernetes doesn't give you too much options to connect outside. I know you can use the outside DNS. It's not the very Kubernetes way. You can use IP, YAC. Okay, you can use this service name, the type external service name, but there is only like the addressing IP to some kind of the name or name to name. Doesn't give you too much flexibility like authorization, etc., etc. And there are a lot of operators created by AWS, for example, that give you access to external resources on the AWS and handle like authentication, etc., etc. So it works like a bridge for you. You can have advanced application autoscaling. That's the pretty popular use case. If the KEDA, HPA, and VPA doesn't suit your needs, then you can write your own autoscaler and decide on wherever, honestly, wherever. You can manage application platform, because what you will get with operator is the magic that it will keep your application state in correct state. You know, imagine again, nasty developer goes to your cluster and deletes some kind of the deployment that you installed with Helm, for example. What will happen? Nothing. You don't have that deployment. That's end of the story. But operator, we see, oh, that deployment is a dependent resource of my custom resource definition, and it needs to be there. So I will create it again. And you have that deployment again. And the last one, but not least, is the security. So in Kubernetes, Airbag works in a way that you can have like permissions on namespace and on particular resources. That's two levels that you can add. So imagine that you don't have access to any Kubernetes parts, but you only have access to the things that you created, like the Postgres database, but not to deployment, not to pods one, like the your application, okay, etc., etc. There are a lot of popular operators. You can get through them, but maybe later. There are also Java operators. There is a Keycloak operator, Apache Flink, Locust, etc., etc. What about Helm? Someone may ask, okay, I give you already one example, but someone will ask, okay, what for I need an operator? I can have Helm charts that are generated, etc., etc. I'm fine with that. I will use Argo CD. So Argo CD will apply Helm charts, and I have the same with like the auto healing. I will have the same thing. Why I need operators? Let's compare them. First of all, with Helm, do I have one cluster installation? Yes, the same with operator. Does it make my Kubernetes application Kubernetes native? Helm, there is a small asterisk. We'll come to that later. Will I have automatic platform configuration possibilities? Like Helm is like the external tool. You apply something and that's it. It will not change state. It will not change to any kind of the conditions, etc. So if you want that, you want to change dynamically, you want to add algorithm there that will change your application, whatever it is, adding networking, removing networking, whatever, you'll need operator for that. Dynamic changes of the configuration, like redeploying stuff in case I will change something. If you change manually config map, and if Helm will change manually config map will be changed. But if your application doesn't support the situation to hot reload that data, it will not know that something changed. With operator, you can mitigate that thing. There is the state management that I already mentioned, that the Kubernetes will take care that every piece of the dependent resource will be there. Do I need to write some code? In case of Helm, you need to write some YAML, basically. In case of operator, probably you will need to write some code, but there is also an asterisk. And out of the cluster resources, if you want to use during the installation of the application some kind of the resources outside of the cluster or connect outside, the Helm doesn't give you that, that possibility. Imagine that you are using like external database and you want to make sure before you deploy your application that database is up and running. With Helm, you will see eventually on the pod that, oh, that pod doesn't connect. With operator, you will be able to have some kind of the preconditions and check everything and give you that output on that resource. So how to write one? First, we need to select language or solution. And there are 3 ways of doing that. First way will be to use operator SDK. The first one, the most native one. And to do so, you need to select one of 3 options. First one will be use Go language. Go language is the most native for Kubernetes. But there are 2 other options, Ansible and Helm. That's pretty strange, and these are the asterisks that I wrote on the previous screen. So there is a Helm operator generator, so you can generate your own operator from Helm directly. It's the fastest way. The same is for Ansible, but Ansible is pretty tricky to configure, but it's doable. With Helm, you can just generate your own operator and have some of the some of the benefits, not all, because you will not be able to write source code that will do like a little bit magic there, but definitely you will be able to keep that state management, etc., and add this operator that will keep your application working and operable. The second way is use operator framework, and there are two operator frameworks: KOPF, Kubernetes Operator Pythonic Framework. This one is for Python, and JO SDK, Java Operator Software Development Kit. And we will focus on that in a second. And the third way, these two are not fit for you. You can write your own operator in bare programming language, like the C#, Kotlin, Rust, whatever. But you will need to handle on your own all these watch events, consume events, etc., etc. In all of these choices, you get that automated. You don't need to write it. Okay, so that makes much difference. Why Go? Go is a native Kubernetes language. Go Kubernetes ecosystem is optimized for developers. Go has good runtime characteristics, memory and CPU, and there are a lot of projects that supports you. Why Helm or Ansible? Yep, you're gaining some of the operator benefits quickly, like in instant. Honestly, in 1 hour you can do it on your machine. In 1 day or 2 days you can do it for the enterprise, except banks, because then it will take 6 months, but not because that takes you 6 months. The approval process will take about that. In case of using Helm, it could be delivered really fast. That's what I said. And less maintenance, because you can regenerate operator if needed, and that will just work. Why Java? That's the proper question on this conference. Maybe it's your company default language. You don't want to add another one. Maybe your application is written in Java and you want to reuse some kind of the libraries that you already written. Why not? Maybe there is no need to upskill your developers. Maybe there are also framework support, and in case of the resources, GraalVM makes Java competitive with Go applications, to be honest, to some extent. But usually operators are pretty simple, and I didn't see too much difference between these two. So the generic approach will be that. If you have Helm chart in your company, just use Helm if you don't need anything specific. If you want to create your operator quickly, just use Helm. If you want complex features, then use Operator SDK Go. Unless you want to keep like single programming language, or you want to stick to particular language, then use Java. And if not, then use whatever. And if nothing in the above, go with Go. Yeah. And this is the official CNCF operator white paper, how to proceed with the operators. But tag is cheap. I already used 25 minutes, so show me the code. And as I will not have time to like real code, but after the talk, I'm happy to show you like the real working code. I will go with the screens. It will be much easier for me and for you, more consumable, I believe. So remember that custom resource definition that you wrote like the 15 minutes ago? Just let's go with the same stuff. This is the same. This will generate this file. Like there is a group, there is version, there are short names, plenty of that, singular, plural, the name. We are extending something what's called custom resource, and custom resource, like any resource in Kubernetes, comes with two things, like the specification and status. So we will define specification and status, and we need to implement it one of the two interfaces. In this case, it's namespace, so namespace. Pretty simple, isn't it? Yep, okay. So let's see to the details. Currency record specification. That could be a record. Why not? And that could be like this. Printer column is something that if you go kubectl get currency rate, it will show you these columns. It will be auto-generated. So there are like you saw that with different resources, there are different columns there, I hope. So that's how you can add them to the output on the console. So that will be that. And in case of the status will be the same. There's some kind of the generators, enums, but the most important part is just that we will have status, rate, state, and some kind of the part for the message. In the case of error, we want to have some space to give, oh, you didn't wrote that one, or there's the incorrect number, or whatever. Yep. So these three pieces will generate you perfectly viable custom resource definition. So how about the code? The code, like this reconciliation. Reconciliation is something like that. That's the single method that you need to implement. And this will be the simplest, yet this will be the worst method that you will be wrote. And I need to share you some details. So imagine that I wrote this currency rate, but I wrote this currency rate with two custom resource definitions, single one currency rate and currency rate cron, to like the automatically get currency rate for certain currencies every day on the cron schedule. So I will already have that in Kubernetes and can use in different applications. That was like the goal. So I am in the currency rate operator. So I do retrieve currency rate for. Unfortunately, that is mutable and that needs to be mutable. So I will set some values there, like the direct connection, etc. In case of the exception, I will like the mark this currency with some kind of the error and currency rate. And in case it's scheduled by something else, so some parent, update parent scheduling currency rate. And this is the thing that you should never do. So the children doesn't update their parents. That's not how the life goes. Okay? Maybe it is actually, but never mind. And then we are updating status. That's the method from the Kubernetes operator, nothing specific, and that's it. Simple, yet not very good, because sub-resources should not update parent resource. That's the first. In case of doing it in that way, we are risking multiple API requests and increase overall load on Kubernetes API. Writing an operator is pretty simple task. You need to watch only for two things. First, don't create the endless loop. And second, don't kill kube API. If you don't do these things, you probably will went fine. So that way also it will be very difficult to maintain. Imagine that this application is scheduled by this application and this by this and this by this, and how you manage that from the bottom level. That's undoable, to be honest. And the last thing, operators in general should use other Kubernetes resources. So I shouldn't do internet connection by myself. I probably should create a job, and job should create a pod, and that pod should download some kind of the value, and I should keep it and get it in the operator. That's how the overall flow should work in a proper way. Maybe not in a way like the currency rate. That will be pretty fine to create like the application that will go to the internet. That's why there is an asterisk. But in more complex solutions, you want to use the Kubernetes resources. So let's do that. Let's imagine our application a little bit more complex, okay? So there will be some kind of the deployment. Deployment will be, will have their service, that how we can connect to this deployment using this service. There will be additional service, some kind of the, I don't know where. There will be secret for database. There will be a config map for some kind of the configuration. And we'll have additional replica set with network policy. This will be our database. Database will have persistent volume claim. Persistent volume claim will have persistent volume. There will be shared secret between these two with database password and user. And there will be service. That's how we connect. It looks pretty complicated, okay? It is? Maybe not extremely complicated, but it's something, you know? So we are coming to something what's called dependent resources. And dependent resources are that you created a custom resource definition, and custom resource definition is using other resources. They might be natural for Kubernetes or additional created custom resource definition. There is nothing wrong with that, okay? And they are following the simple, very simple algorithm and pattern that you need to remember, but probably you will remember that forever after this session. Compute desired secondary resource. So imagine I created this currency rate scheduled, and I am computing currency rate. Secondary resource exists, that's what I'm computing. If no, then create it, done. If it's already created, then match desired state. Remember declarative approach? What Kubernetes does here is looking what you wanted and what it is. And if there is some kind of the diff between these two, then we need to update that. We need to update that and done. If everything matches, then we are just done. Simple algorithm as it is. That's the job of the Kubernetes. You don't need to write that, you just need to know that. So let's write reconciliation in a better way. For that, I will use different example. Imagine that we are creating Spotify API operator. Just an operator to give me access to Spotify. What it should do? It should have some kind of the configuration. for filtering for the market, like we are only want to filter for Polish market, etc. And then this operator should spin off the required number of instances of Kubernetes, of Spotify API deployments. So this one will create API deployments and also a service. So after applying Spotify API, I should have service and I should have operator, deployment that will give me a pod that I'll be able to connect to Spotify using that kind of the local service and local interface. So that's how the usually reconciliation works in Java. So I logged myself. That's the pretty hardest way here. And then I do some kind of the trick, and this is the usual trick. If you have some kind of the requirements, it needs to be added to the API, but you want to make that optional. Like you don't want the user to set it. You wanted to push them to set it, but it's really, really required for your application to be operable. You want to do such kind of the things. If there is some kind of the value like instances, how many instances of this deployment should I roll out? And it's set to null, then I want to set this number of instances and update resource. This is a pretty important thing. By updating resource, I will invoke another event. So it will go, so I can finish here and it will go other way around. And at the second run, get instances will not be null. So then you will go here. So there will be retrieve current status for AP context and update status. That's it. So I'm just retrieving status for the API. I'm not doing anything specific here. No calls, no everything, no online like the internet calls or whatever. And update status with the status that I just received. We will be using dependent resources, and you can just in Java create that dependent resources extending CRUD Kubernetes dependent resource, and there is also the resource that you are depend on, and your custom resource definition class. So these two things, and by doing that, you will need to add this simple method like this called desired for the Spotify API resource, for the context that you are running on, so you can change something in case of the context, generating some kind of the name here. And then, you know that when you define the resource, you have the metadata, you have specifications. So the metadata name, namespace, labels, you are getting that from there. And the specification is generated in like that way. No, not that way. I need to show that in the source code, but you just can have like the all values one after one. But in case of longer resources, like deployment, you can eventually finish with something like that. So you need to really watch out to make a little bit proper code, because that doesn't do, that's like not very readable. No, it is like metadata, spec, but it's really inconvenient to write something like that, to be honest. But you certainly can do it in that way. That's not a very good example how to write it. And that's it. That's how you can create the operator. Imagine that you can sometimes create dependent resource depending on your context, sometimes not, depending on the input that you already receive. I don't know if you saw that, but you are getting current custom resource definition that user applied on your cluster like an input to the method, and with the context, so what's running, what's there, is it something running, is it not, etc., etc. So with all of that, you can just define a couple of classes and you are ready to go. If you have something tricky like checking, okay, so something happened, I want to reach out to something, you can add some kind of the cron method that will reach out to your resources and check something, or you can add connection to Prometheus to scale out or whatever, but please don't write another KEDA. KEDA is pretty fine for that, and KEDA is an operator actually, so that's how it works. So the thing that you need to think about is the status. The status is the heart of the operator that will give you a lot of information. So remember to do, maybe I will close it up. Remember to do some kind of it's the standard, like add conditions. This is the list of the things that happen for the operator, something like a log for you, and you are keeping it in the very, very flat resource definition status place. So anyone will be able to go there, apart from the logs that obviously you want logs, metrics for Prometheus, etc., you also want to have something like this short log here. That's pretty important. These are the printer columns. So if I go kubectl get currency rate, I can have like that. That's pretty nice and simple, isn't it? Yeah, it's how you want to work with Kubernetes native applications. Like I'm getting that, and I'm giving all the information that I probably will need. And there are also some kind of the additional things like output white, output JSON, and you can like tangle with that, and you get that everything just for free because Kubernetes will take handle for that. So there are several best practices if you want to go and create your own operator. One operator per managed application. Don't create two operators that will manage the single custom resource definition. You don't want that kind of the hazard. Multiple operators should be used for complex multi-tier application stacks. Custom resource definitions can only be owned by a single operator, already told that, and shared custom resource definitions should be owned by a separate operator. I will come to that in a second. One controller per custom resource definition. Use a tool like Operator SDK. Please don't try to, unless for like the scientific purposes, don't write your own operator in other languages. That's like a pretty inconvenient. You know why there is the Java Operator SDK? It was written by Red Hat just because of one of these purposes. They didn't want to extend the language stack. They want to keep it in Java, and to wrote the Kubernetes or keyclock operator, they wrote the Java operator SDK. That was the purpose, and that's how it goes. And they are maintaining that, so it's pretty stable and it's not going anywhere. And please do not hard code namespaces or and resources names. They should be all generated. And why do not hard code namespaces? Imagine that someone would like to run two operators. And there is always installing operator something like watch namespaces flag, or it's usually called that, but sometimes it's called a little bit different. What does it mean? It doesn't mean that your operator will operate on custom resource definitions only on certain namespaces, and will skip all of the rest. By doing that, and by doing this kind of the configuration option for administrators or DevOps, you give them chance to install two operators with different conditions, if there is a case for that. Make watch namespace configurable. Use Semver observe Kubernetes guidelines on versioning API. It's pretty important to follow the guidelines because Kubernetes, especially any kind of the cloud version Kubernetes, will not allow you to break the rules. And there are certain rules like the A1, Alpha 1 can be deprecated by A1, Beta 1. But to deprecate any higher version, you need additional higher versions. So to deprecate V1, you will need V2 deployed, and V1 should be at least for one Kubernetes version available. So you will need to deploy V2, and when you deploy V3, the V1 can be deprecated and deleted. So first it's called deprecated, and then it's called then after that you can delete that. Use OpenAPI specification. It's pretty simple. Operators expose metrics to external systems, Prometheus or wherever, OpenTelemetry, whatever you use. And operators should clean up resources on deletion. So if someone will delete operator, anything that was created by that operator should also be deleted. Okay, that's pretty important, and it's not like they pushed by the Kubernetes straight away. So I said that one operator for each application, so for each CRD, that means I will need plenty of operators. Who will operate the operators? And there's a pattern for that, and it calls operator of operators pattern. So you create custom resource definitions, and you create operators for these particular custom resource definitions. That's way it keeps simply the single operator. Operators should be really, really simple and really fast. So if you create multiple of them, then you can create something like my system operator with the one shared configuration with all the pieces and all the defaults that you want to apply. And this will create the CRDs. It will not create these pieces. It will create the additional CRDs, and that way your system will just come to life, and you can have any kind of complex system installed just by one YAML file. How cool is that, and how difficult to achieve? What's next? Error handling and resilience. That's the part that you need to go a little bit dive how the Kubernetes works and keep the status. But it's pretty simple. It requires some kind of the time with that, but it's pretty simple. Effective status conditions, like the statuses, conditions, what should you put in the logs of the operator. Configurability and deployment of the operator. The easiest way to deploy an operator is use Helm. Again, Helm operator can be a YAML. YAML applied by Helm with some kind of the internal values, and then the operator is up and running. Operator should usually run in separated namespace. You probably see some kind of the kube system, and the controller manager from the very beginning is an operator. And in the first version, I believe it was separated applications for each kind of the custom resource definition, like the deployment pod, etc., etc. But they just took all of these operators into single package, single application. But there are still different operators. You can do such thing, and you can install using Helm your operator. Where to start your journey? You can go with Java Operators SDK. You can go to Quarkus Kubernetes client. And a little bit more of that. The Spring Boot also had this Joe SDK starter. I don't like it too much. That's a little bit difficult. But the Quarkus have great Quarkus operating frameworks. It's like, it just works, it's lovely, it's simple, and it's easily compiled to GraalVM. So like you already have that built in. There are also all best practices. You can see that on the video. And I believe that's it. Do you have any questions? I can show you a demo in 1 minute. A lot of information, but let's say I will make that a little bit bigger. Dismiss tip. So I believe that you can see everything. There is nothing running there. Yep, that's correct. I have here this Spotify API. This is my Spotify API, Spotify Global, 2 instances, and this is one of the patterns that you are expecting to add some kind of the secret created externally. So I am just, the secret for my API is here, so the operator just needs to do that as an input. Okay, apply Spotify API, that's it. Let's see what happened. Okay, clock Spotify API. That's an input output. I'm not sure if that will work, but okay, clock PO will probably work. Why is that working? Okay, I will do like that. The more, oh, I don't have internet here. That might be it. Okay, get Spotify API, default secret rage. That might be it. Give me a second. Kubernetes will work with that. Metropolo. I don't know the password. Anyone know the password? Is it somewhere here? Oh, okay. Oh, so kebab case. You should say that already. Okay. No. Oh, okay. That would be that. Come on. Deploy. Not it. Spotify API. Maybe. Let's do like that. I deleted that one. Apply. Okay. It's working. It's working. Okay. The gods of demo are abandoned me. Spotify API. Instances, resource version. I don't know. Why isn't it working? Sorry, but it's not working. It was working 1 hour ago. Maybe we can delete. that one. Apply. I need to create a secret. Oh, it already exists. Apply. Spotify PL API. Oh, I know why it isn't working. I don't have this operator running. It's just like I didn't deploy it there. So op Spotify. Okay, that will be here. Spotify operator. Let's run it in the most simple way. That should work. Okay, get Spotify API. It's already there. And now it is like a lot of things happening. So let's delete that one. Okay, delete. I created the PL version, isn't I? Okay. Okay, get PO. There is nothing there. Okay, apply Spotify API. You see some logs on the right side. Clock, pod, and it's running. Woo! Like that. And also service. And as you can see, there is pods, services, and deployments. And the replica set also created for deployment just by applying the operator and applying the Kubernetes. And see what will happen. Okay, get deploy. So I have one deploy, and I am a nasty developer. Delete, deploy. Like I deleted that one. Yeah? And it's already there. So that maybe I can do that a little bit differently. Okay, clock PO. So you will see pods running there. Okay, delete deployment. They are deleted and started to be recreated again just after a second, because operator takes care of that. And imagine that I didn't give privilege for operator to anyone. So if there will be someone that are debugging stuff and by accident just delete deployment, nothing will happen. That will just go like that. Thank you very much.